Hello again. Now I'm going to explain a simple experiment used to make zinc sulfate crystals. So there is a student, she made a zinc sulfate and she wrote all the steps. So let's understand how she made it. So the first step, 25 cubic centimeter of dilute sulfuric acid in a beaker was placed on a tripod and gauze and gently heated. So after adding 25 cubic centimeter of dilute sulfuric acid, she placed it on a tripod of gaze and heated it gently. So after each step, she asked questions to tell us why she did that. So the first question is, why did she heat the dilute sulfuric acid? What do you think? Why did she heat the dilute sulfuric acid? We know that the heat increased the rate of the reaction. So to make the reaction go more quickly or faster, we heat it. So this is the answer of the first question. The second step, zinc powder was added using a spatula until the reaction was complete. So zinc powder was added using a spatula until the reaction was complete. So the question here, state two observations that would tell her that the reaction was complete. So if no more gas is giving off and no more zinc powder dissolves, so the reaction here was complete. So two observations. The first one, no more gas given off and no more zinc powder dissolves. Step number 3, the mixture was poured through a filter funnel and the filtrate was collected in a warm evaporating basin. So what remained as the residue in the filter paper? What do you think? What is the residue in the filter paper? We know that we added zinc powder, so the unreacted zinc powder will residue in the filter paper. Okay, for question number 4, why was this added? Actually, she made this step just to make sure that all of the acid had been used up. So what color was the filtrate? When you see the experiment in the YouTube, you will find that is the color of the zinc sulfate solution is colorless. So actually the color of filtrate is colorless. It's a transparent solution. So step number 4, the evaporating basin was covered with a piece of filter paper and left to cool in the laboratory overnight. So why did she place a filter paper over the evaporating basin? What do you think? Why did she place a filter paper over the evaporating basin? Actually, she added it to stop dust getting into the solution. So lots of tiny crystals didn't form. So if dust getting into the solution, lots of tiny crystals didn't form. So to prevent that, she added or covered it by using a filter paper. So question 7, why did she warm the evaporating basin before adding the filtrate and then allow it to cool slowly? We said that she wanted to make large crystals so that big crystals would form when it cools slowly. Okay, question number 8, write a simple equation for the reaction. So we added zinc powder, which is Zn, and we added diluted sulfuric acid, which is H2SO4, that will produce zinc sulfate, ZnSO4, and hydrogen gas H2. So let's watch this video to see the experiment.
This is a demonstration video showing the chemical synthesis of zinc sulphate by the chemical reaction between metallic zinc and sulfuric acid. The metallic zinc we've harvested from some scrap wheel balancing weights used on cars. Within these weights there is a small steel tab used to secure them to the car wheel. We've removed this using a hacksaw. Now we add our chopped up pieces of zinc to our reaction vessel. The reaction vessel, by the way, is connected using some rubber tubing to a gas bubbler, as we expect some gas to be produced when zinc metal reacts with sulfuric acid. Now, using a small glass funnel, we add some sulfuric acid to our reaction vessel. The sulfuric acid, by the way, was harvested from a lead acid battery by filtering the electrolyte. Now with a bung fitted to our reaction vessel, you can clearly see some gases being produced and it's bubbling through our bubbler. This gas, of course, is hydrogen. The chemical reaction which is taking place is that metallic zinc is reacting with sulfuric acid to form zinc sulphate and hydrogen gas. If we attach a balloon to the end of our bubbler, we can capture the hydrogen gas which is being produced. And of course, hydrogen gas is less dense than air, so the balloon floats. Once all the sulfuric acid has reacted, this is indicated by no more bubbling and the presence of unreacted metallic zinc in the bottom of our reaction vessel, then we can filter our solution. As zinc sulphate is water soluble, filtering the solution will allow the zinc sulphate to pass through the filter, whilst leaving behind all unreacted material. Zinc sulphate, when dissolved in water, is a clear, transparent liquid. To remove the water and leave behind the zinc sulphate, we pour our solution into an evaporation dish and allow the water to evaporate. We can speed up the evaporation of water using a hot plate, as elevated temperatures will help drive off the water. As water is removed, we will start to form some zinc sulphate crystals. And with a little more time for the water to evaporate, we start to form a dry powder, which is very easy to break apart into a finer powder, and this is a successful synthesis of our zinc sulphate. And the big question some of us may have been asking, what happens if you light a balloon full of hydrogen gas? Well, the obvious, it explodes. Thanks for watching.
So in this experiment, he used zinc pieces instead of zinc powder. So the idea that when we add zinc into the sulfuric acid, that will produce zinc sulfate and hydrogen gas. So I'm gonna send the worksheet that I explained before to the B12, and please try to answer the questions alone, then check your answer from the answer sheet. So thank you for listening and study well. Good luck. Goodbye.